My name is Saurav Datta, and today I welcome you all on behalf of the Department of Oceanography, Techno India University, West for this seminar series, which has been brought to you by Techno India University, West Bengal, and the institution's Innovation Council, Ministry of HRD Initiative. So today we are going to listen to a wonderful talk by Dr. Susanta, who is the national manager and the national manager for the Coca-Cola Beverage Private Limited, and it is going to be on a business model canvas. So, but before that, we have with us our yeah, we have with us Dr. Rina Paladi. Is she there? Is Professor Dr. Rina Paladi there?
Your voice is cracking.
Madam, can you hear me now? Hello.
Yes.
Am I audible, madam?
Your voice is cracking. Yes.
The problem with the internet connection, but I think I'm audible. Okay. So, hello.
You're audible.
Yes, you're audible. You're audible.
Yes. Thank you. Thank you so much. Thank you so much for the confirmation. I apologize for that problem. There
Yes.
seems to be some problem with my internet connection, but I'll try to keep it short. So we have with us today Professor Helena Sengupta, madam, and she's the HOD of the Department of Civil Engineering, Technical University, uh, West Bengal, and Chief Advisor, Industry Relations and Placement. So, madam, will you please address this session?
Director madam has joined. Dr. Shorav, our director madam has joined, so she will give her the welcome address for this session. Yes. Please introduce her.
Okay, madam. Okay, madam. We will be hearing from Professor Helena Sengupta in a while. But before that, I would like to request Professor Dr. Rina Paladi, our Director, Technical University, West Bengal, to please address the session and with a few words. Madam, if you please.
Yes, am I audible?
Yes, madam. Yes, loud and
Yes.
clear.
Good evening, respected dignitaries. Professor Dr. Abhijit Mitra, Director Research, Techno India University, West Bengal. Professor Dr. Sufia Zaman, Head of the Department Oceanography, my dear colleagues, my beloved students and participants. On behalf of Techno India University, West Bengal, I take this opportunity to extend a warm and hearty welcome to you all in the virtual session on an important topic, that is the business model canvas organized by the Department of Oceanography in association with Institution Innovation Council, Techno India University, West Bengal. Business model canvas is a language for describing, visualizing, assessing, and even changing the business model. There are different elements and steps of a strong business model. I hope the participants will be able to enrich themselves on this business model canvas, which is very much essential those who want to start a new business or want to change the business. So on behalf of Techno India University, a warm and hearty welcome to Dr. Susanta Poddar, National Manager, Coca-Cola Beverages Private Limited, and Adjunct Associate Professor, Lincoln University College, Malaysia. Thank you so much, sir, for sparing your valuable time for the Techno India University, and I hope your valuable talk will enrich all the participants on the topic. I'd like to congratulate and compliment the entire department and the IIC to organize this event, most relevant event on such a topic. So I wish all the best. Enjoy your session. Take care and be safe. Thank you.
Thank you, madam, for those wise words. We have also with us Mr. Ravi Ranjan. So he is the Chief of Entrepreneurship and Innovation Strategy and Head of New Age Programs, President's Institution Innovation Council. So, sir, if you will kindly address the session.
Sure. I think I would like to first welcome, and I would like to share my thoughts at the end of the session. I think we can start with the speaker at the moment because that is more important. I would come again at the end of the session. Thank you.
Sure, sir. We would also like to hear from Professor Helena Sengupta, madam. Madam, please, if you may kindly address the session before we begin with our talk.
Yeah, thank you so much. On behalf of IIC Techno India University, I wish a very good evening to all the panelists, the organizers, and all those who have joined today's session. Today's topic has been organized to encourage the aspiring entrepreneurs and give them a fair understanding about this tool. Business model canvas serves as a template entrepreneurs can use to visualize and map the major elements of their business model. A business model is where entrepreneurs place the building blocks of their business. It's where they arrange them into a functional system. This is a critical step in the development of a business that requires a methodical approach. Now, this business model canvas is generally it is used to quickly draw a picture of what the idea details. It allows us to get an understanding of the business and to go through the process of making connections between what your idea is and how to make it into a business. It looks at what kinds of customer decisions influence the use of your system, and it allows everyone to get a clear idea of what the business will likely be. I'm confident that all of you would gain a lot out of today's session by Dr. Susanta Poddar, and I wish you all the best. Thank you so much. Please take the session further. Thank you so much.
Thank you, madam, for those words. And we are joined by our beloved sir and guide, Dr. Abhijit Mitra, sir, who is the Research Director of Techno University, West Bengal. Sir, we are all waiting to hear from you, some words from you, sir.
Oh, am I audible?
Sir, loud and clear, sir.
Okay. So, good afternoon to everybody who have participated in this program. This program is really a unique venture to initiate the young scholars, young students to start their career. But what is very important is that some important point need to be mentioned. The backdrop. When you are starting this type of entrepreneurship or starting this as a part of the business model, two things are very important at the present moment. Number one is the COVID situation. In the COVID situation, the GDP of all the nations, irrespective throughout the world, has dropped almost to a negative. This is number one. We have to keep it in mind. Many persons have lost their job. Many organizations have shut down their door forever. Many of the corporate sectors have taken their different dimensions and decisions. So these are very important. At this present moment, if we can develop our own model, we are incapable to fight against the nature. It's not possible, however advanced and whatever technology we have. This is number one point. At this point of view, I think in this critical juncture, this entrepreneurship development will give a moral boost. And number two is that you have seen for the last 1 week how the total planet is taking a turn towards the nuclear war. It's not a war between the Ukraine and Russia, but it has impacted the whole planet. That is to be kept in mind. The price will rise. The oil hike has already started throughout the world, and India is no exception, and West Bengal is no exception to this rule. So we have to take all this thing into account, that the entrepreneurship or the business model should be based on minimum energy. The energy conservation, the energy cycling, the eco-restoration of the ecological systems, these are very important. So I believe that I have seen the brochure. Tomorrow will be the pisciculture, the how to culture the fish in artificial tanks. Well, these are very good because they are supplying proteins to the people all over the nations, those who are non-veg. And fish has got an important role, not only not only from the point of view of nutrition, but the point of view of livelihood. But I will not take much time because the expert Dr. Pallavi Datta is there and she will be speaking on that topic tomorrow. So I wish every success of this program. Thank you.
Thank you, sir, for that wise words. Really, we are at this juncture where there is really it's very what is going to happen. We are not sure of that, and we need to think of innovative ways to come out of such problems. So right now, I would like to request all the panelists to please switch on their videos so that a screenshot can be taken. Uh, so panelists, if you will please.
Dr. Poddar, he's joining.
Okay, so we will wait for Dr. Poddar, and after that we'll take a screenshot.
Yes. You can introduce Dr. Poddar. His introduction you can do carry on.
Yeah. So today we are going to listen to Dr. Susanta Poddar, and he is the National Manager of Coca-Cola Beverages Private Limited, and also the Adjunct Associate Professor, Lincoln University College, Malaysia. So he has been the visiting faculty at the University of Kalyani and the expert panel member for Indian Chamber of Commerce for Occupational Health and Safety. He's also the bloggers for the Royal Society for the Prevention of Accidents, and he's also in the editorial board member of the International Journal of American Journal of Science, Engineering and Technology uh, from the United States of America. He's also a functional area expert for Hazard and Risk Approved Quality Council of India, Government of India, and he has 16 years of industrial consulting and auditing experience in Coca-Cola with Aditya Birla Group, PepsiCo, India, Lafarge, Holcim in Tata Chemicals, and Ambuja Cement. And he has also published several research articles in reputed national and international journals and received numerous national and international awards. So before we listen to Dr. Susanta Poddar, I would like to request all the panelists, please switch on your video so a screenshot can be taken. So panelists, if you may.
I think Dr. Orpita Saha and Dr. Pallavi Datta could not reach into the video.
Yes, madam is there. So I think we will begin our session right now.
Dr. Poddar, he is actually in the airport just right now for an emergency work. So he has sent us a video recording of his entire talk for this session. So Dr. Poddar, would you like to say a few words before we start your session? He's there?
Audible?
Yeah,
Yes,
you,
sir. Yes, sir.
Yeah,
you
I'm
are
so
there.
sorry. So right now I'm in airport right now. So just boarding is going on. So that's why I just shared my recorded video. Anyway, I'll try to connect to my mobile and let's see. But yes, my just boarding is going on right now. Yeah, I'm so sorry.
it is okay, sir. So sir has been kind enough to send us a recording for his talk. So we will listen to that, and we will share his email in the question box if any questions arise. So I will like to begin with your permission. I would like to start the recording, sir.
Yes.
I hope my screen is audible to all. It's
Yes,
visible.
yes.
Okay.
Yes, sort of. Yes.
First of all, I would like to thank the organizing committee, Department of Oceanography,
the Techno India University. And my special thanks to Dr. Supriya Jaman, who has invited me give a lecture on business model canvas. So our business model canvas means that you as an entrepreneur are able to focus on the core components that go into building a solid business plan and can avoid the needless details that can be sorted out later. As a sustainability and EHS professional and being associated with different multinational company like Tata, Aditya Birla, PepsiCo India, Lafarge Holcim, Coca-Cola India, and came across a different multi-dimensional business vertical where sustainability and ESG is one of the core business models. So my presentations will focus on few sustainable business case model where one can adopt some process or technology and can able to build their own business. And literally I'm telling that there is a huge scope in sustainable entrepreneurship and green economy. As I'm just stating that as we are working in the field of sustainability and ESG, and one of the big challenges for the industry is managing the waste. So one concept is managing the waste and how you are converting a waste to a sustainable manner, converting a waste to a wealth, correct? And we can term as a waste to wealth entrepreneurship. So first of all, we'd like to know what is waste and what are the main sources of the waste. So if you see literally, there are two sources. One is ozone from our waste are coming out. Another is a commerce and industry. So basically, where I am from, from the industry, and where we are managing different kind of waste, and for that we have to manage a lot of legal obligations. So waste are unwanted or unusable objects or materials which are discarded after primary use or declared as worthless, defective, and of no use. So now the waste can be converted either on site or it can be converted in an off-site recovery facility. So there are different technology available in the markets. So like physical or chemical technology, technology called reverse osmosis, electrolysis, condensation, filtration, centrifugation process, etc., etc. So when waste is generated, so the waste is segregated in different fashion. Then the waste is collected, and finally it reaches out to the different recovery plan. Now the waste are converted in different technology, like it can be converted as energy, like it may be a fuel, it may be used as a gas, or it may be used as a electricity. And for that we have separate slides. At least you can have some idea how the waste can be converted in a different recyclable unit and converted as a fuel, gas, or electricity as a energy product. So this is basically nothing but a hierarchy of waste management. So the least preferred option is disposal. So as a sustainability professional and as a good citizen, we should avoid the disposal. So we should adopt the most preferred option, that is a prevention. Means at the source, you need to sorting the entire kind of waste. It may be a household waste, it may be a industrial waste, it may be a farmland, or waste coming from the public facilities. Then the second option would be a reduction. So within the production side and within the consumption facility, so one can adopt some technology to reduce the waste. Third option is what? Third option is the recycling, where the production, distribution, and consumption process is interlinked. So whatever waste you are producing, you are recycling in your own process. Correct. So it's kind of your closed circuit system. Fourth option is a recovery. So within the production process, you can recover the entire waste. And already I explained that disposal is the least preferred options, where most waste are disposed of at the landfill. Correct. So like there is a different regulations for waste management. Like if I refer the hazardous waste, obviously for that hazardous waste management and handling rules are there. In I think it's amended in 2016, and later it was amended in 2020. Likewise, we'll find like there is a separate rules for the demolition waste. There is a separate rule for the battery waste, electronic waste, plastic waste, and even for the municipal waste. Now, my first approach is how we can convert waste to wealth. So there is a business case study. If you ever visit any food industry, like industry like PepsiCo, or industry like Haldiram's, where different kinds of food ingredients like chips are manufactured. So for them, potato is one of the raw materials, correct, or ingredients for them. And perhaps you know that in a particular potato processing plant can generate around 6 to 10% of potato pills. Okay, so we termed as a chilka. Okay, so it's a pills, and in the peeling process, so this pills are basically discarded material, coming out from the food processing industry, and these pills are dumped as a waste product. But if you see the calorific value of the potato pills, it's around 17 megajoule per kg. It's a huge calorific value, and one can easily convert this waste material as a energy intensive or calorific intensive product. So the option for waste management of potato pills is by the some anaerobic digestion to produce a methane and electricity. So like I'm giving one example where an industry like food processing industry generate huge quantity of pills, and from the pills they can generate the methane and electricity. For them, these pills are a waste product, and finally it's going to the dumping yard as a landfill material. So the waste potato pills can send to the any scrap collecting facility, and that will process it to get a biofertilizer. And we can also reuse the potato pills in a biomethanation plant to generate electricity. So there are two parts. So first part, from potato pills we can generate methane and electricity, and the second part, if we can have some fermentation process, and from there we can converted the potato peels as a biofertilizer. Correct. So the garbage produced from the plant have been mixed and dumped into a heap. Then the mixture will be kept for the decomposition, and after almost 40 days, the heap will be separated over for the drying process. So if you visit like Hapa, so you'll find one industry is there, like so they are basically collecting all the municipal waste. They are collecting all the biodegradable like waste from the food industries, like potato peels is one of the biodegradable waste, where they can get use quantity of this thing calorific value. So first of all, they can convert as a biofertilizer. Parallelly, they can convert the same as a methane, and from methane it's converted to electricity. Okay, so some pictorials form. If you go to the Dhapa, you will find this facility. So I'm not taking the name of that particular industry, but yes, they are collecting all these garbage material from different markets, and obviously from the food industries. And finally, the heap garbage are converted to a drying compost. Now there are some they have some installation process, some engineering and technology process are involved here. Like they have installed magnetic separator, installed conveyors, they have installed different kind of mesh from what they segregate composting materials. Correct. So in the left side, you'll find that the compost is placed in a conveyor belt for segregation. So what happened? So whenever they are putting all the material, like composting materials, this composting material is comprising of the plastic material as well, or metal particle as well. So they are just segregating out the plastic and the metal part. Then the composting part is separated out and going through this conveyor belt. So after segregating all this material, this composting material are passed through a different meshes, like 40 mm or 20 mm meshes are there. Then finally there is a process called segregation. Then they collect the material. Again there are some fine segregations are there. So like 2 mm or 3 mm meshes are there, and finally they get this finished product. Okay, and finally this finished product are bagged into different brand names. Correct? I am not taking the name of the brands, but yes, this is purely a biofertilizer they are producing, and their main raw materials are different kind of biodegradable waste. Correct. So now the second case study that is linked with this potato peels, that how one can convert it the potato peels in a biogas. Okay, like methane. So basically, if you see the retention time of potato peels is very high because of there is a material called lignin. Okay, so you'll find the lignin in the peeling portions. So that's why we did some experimental study, and like we use some chemicals like sodium hydroxide is chemicals. We have taken different concentration like 2%, 4%, 8%, and 10%. First, the sample of potato peelings were collected, and then then grinded through a mesh called 2.mm. Then the peeling wire transferred in a different conical flask for pre-treatment with alkali. So basically, it's nothing but a pre-treatment process. Now we are just observing, so whether we can reduce the retention time called 40 days to like 20 days. Okay, so that's why we are doing some kind of alkali treatment. So after this study, so there is the entire study you find here, like schematic experimental setup, how we set up this process. It's basically a lab scale trial. So first you'll find the screener, then potato peeling process, then grinded a small mesh size, then we did some pre-treatment with 8% sodium hydroxide. Then after 2 hours, wash out the excess NaOH, then control the pH and ensure that the pH would be like 6.5 to 7.5. Then we mixed with the sludge in 2:1 ratio. So here there is a mixing between sludge and pills. So sludge is basically coming out from the different waste recovery plant, like it may be a effluent treatment plant for our industry, and for domestic purpose it termed as a STP, sewage treatment plant. So even we can convert the convert the waste product like sludge as a methane or any kind of energy intensive product. Okay, so then they are passing through a digester, and digester already explained that it's totally an anaerobic process, and after 15 to 20 days it generates biogas. Okay, biogas is nothing but electricity, and it is converted to a biogenerator. You will get the energy, and in another part you'll get a slurry. Then this slurry will be converted to compost, and we can have this get this fertilizer. So this is the entire schematic diagram of the whole process of this converting of food waste to methane and fertilizer. Okay, so that is one success story from where we can get energy as well as the biofertilizer. Now, this is the second case study. So where one can have some idea how they can convert the ash, means boiler ash, to a energy intensive product. So basically, for any boiler, so we need raw materials like coal, or it may be a husk. So basically, coal is non-renewable resources, and obviously, if you burn coals, that will triggers the emission of the GHG, greenhouse gases, like carbon dioxide and another product. So we normally, as a sustainability professional, encourage not to use non-renewable resources like coal that generate huge amount of greenhouse gases. So basically, now a lot of industries are coming up with using alternate energy resources like rice husk. So rice husk is again a waste product. So these are the waste product for rice mill, correct? So when our industry using this waste product, so obviously this rice husk having a high calorific value, correct? But the issue is that, so when they use this rice husk, so after burning of rice husk, so they get the boiler ash. So this ash is nothing but a waste product for the boiler operating units or boiler operating facility. But here one can convert or one can extract some usable products called microsilica biomass pellets, and this microsilica, which is mainly used in construction and cement industry. Correct. Like rice husk in a fleck form and the nodular form, which is mainly used in the steel industry. Correct. So one can, use this waste material, just segregate and isolate the, microsilica or, biomass pellet, and that can be used in like, different industry called, dairies, foundries or boilers. So again, it's a waste and wealth concept. Correct. Third one. So perhaps you can see in the bottom of the picture that is a soap, correct? So although if you visit any food processing industry, so basically they are using a different kind of vegetable oils, correct? And scrap chips and used oil are generated as a waste product after main manufacturing of any chips industries, and some facilities receive the scrap chips and waste oil from the manufacturing industries. Then after processing the entire waste chips, they make the poultry and cattle feed products. So basically what happened? So the discarded food products called chips, they are having a oil content. Correct. So they collect these waste chip products and extract the oil. And after extracting the oil, this can be used as a poultry or cattle feeds. Correct. And lot of ancillary industries are there. You can find that they are just collecting the product, this waste product, and finally they are producing poultry or cattle feed ingredients. And whenever they extracting the oil, so basically this oil, this vegetable oil, can be used as one of the raw materials for the soap industries. So from that oil or vegetable oil through a saponification process, they used the soap product. So that is another use of converting of waste to oil. Now I'm coming to another case study where first of all one can reduce the GHG emissions, greenhouse gas emission. Parallelly, that can reduce the fuel cost. So we are just I'm just putting some benefits like 36% of reduction in the fuel cost. Annual saving is around 6.45 crores. We can reduce CO2 emission up to 6,000 plus metric ton per year, and obviously it's a more than 80% of the total energy is a renewable energy, renewable resources. Correct. So already I explained in my previous business case study that nowadays industries are adopting alternate fuels like boilers. Basically, instead of using a coal like conventional energy, industries are using a rice husk. Correct. So if an industry is using a rice husk, so at least they can have this kind of reduction pattern in terms of GHG. Correct. Even so, one can identify this. If you visit in Bardhaman and this area, you'll find a lot of rice industries are there, and for them disposal is a big challenge because for them husk is a waste product and they don't have enough space to dispose them. And if you have some solid business model, how to convert this husk to energy, so obviously I think that would be a good idea, and you can think of, and you can connect with different ancillary industries accordingly. My Next, waste to wealth approach is like converting of fly ash to bricks. So basically, fly ash is an alternate building materials for low cost housing. And perhaps all of you know that fly ash is generated from the power industries and utilized 100% in cement plants and brick manufacturing industries. And fly ash bricks are a sustainable and low cost alternative building material. So now, what is fly ash? So for a power industries, basically the main source is coal. So after burning of coal, then you are getting a fly ash. And nowadays, lot of compulsions are there. Like there are different rules and regulations given by the Ministry of Environment, Forest and Climate Change, and even there are specific guidelines given by the Central Pollution Control Board that you cannot, dump fly ash. For that, you must have some, solution. So this fly ash can be converted as an alternate material. Like one can, send this fly ash to the cement industry. For cement industry who are producing PPC cement like Portland pozzolana cement. So for them, fly ash is one of the raw materials. So basically, they are using kind of 30 to 33% fly ash to produce Portland pozzolana cement. So that is one aspect. So one can convert it the fly ash to cement industry. Even you'll find a lot of mini cement industries are there, like in Bakura, in Barjora, in Durgapur side. So basically, they are collecting the fly ash, they mix with the limestone and convert it as a PPC cement. So that is one business model one can think, and there are very nominal investment. Correct. Then second thought is that you can use a fly ash and convert it as a fly ash mix. And for them also you need a very nominal investment, and you can easily build this kind of business, and that is one of the sustainable solution. Okay. So there are different rates. Okay, like this startup reduce the destruction caused by the construction of the building carbon negative bricks, and one of the example of Green Jam. So Green Jam is a clean tech startup that offers free environment friendly building materials. That is Binder TM. These are the the brand name. Basically, you can go to the site and have some holistic view. There are some brand name. Basically, Green TM, then Prop Block TM. So is again a carbon negative building materials made from the stalks of the cannabis plants, and Binder TM, and it is used for non-structural wall and insulation material. Okay. Now the seventh option is kind of already I explained, but anyway, like for any food industries, like they're having huge quantity of rejected chips, and this rejected chips can be converted as a cattle feed products. So that is crushed and then shifted to cattle feed industries. Another conversion is kind of for food industries, like managing of plastic waste is a huge challenge. So that plastic you cannot incinerate. So if you incinerate, so obviously there is a huge contamination, there is a huge pollution. Correct. So you can convert the laminates or free waste into different furnitures, or conversion of different kind of boards. So that may be happen. Even from these laminates, you can convert, oils as well as, gaseous product. I think I have a separate slide for that. Yeah, correct. Yes. So the eighth case study is it's a polycrack process. So polycrack is the world's first heterogeneous catalytic process which converts all type of mixed waste into useful resources like gas, LDO, water, and carbon on the same day. Like if you are feeding the material in day one, obviously you will get all the byproduct and end product the same day. Correct. So if you are feeding any kind of plastics or packaging material, e-waste or agro-plastic or organic waste, so that is converted through a polycrack process, and finally you will get through a catalytic conversion process, light diesel oil, carbon, LDO, synthetic gas, water. But here the issue is that the investment is correct. So this is a schematic diagram how the process goes. So there will be some input of waste. This is basically a reactor. Okay. So in the output you will get a carbon product. Then the input waste will be passing through a catalytic converter, and there is a condenser. So in the condensing process, basically you will get hot water, okay, and that is connected with a very small cooling tower. Then through a cooling tower, the cold water is injecting, correct. In the output, you'll find the gas in terms of methane. You'll get like LDO, HSD that is being stored in the primary tank, and there is a filtration chamber, and after filtration you will get the final product, and you'll get the water, and this water can be recirculated the entire process. So that is called the polycrack process, and it's a very, very unique process. Okay, so in one shot you can convert all the waste material, correct, and you can get oil, you can get gas, you can get water. So this is some material study of the material balance, like input and output. If this much you can inject, correct, like 14,714. So that is an input material. So we have did some trial study, and we found that around 2,500 carbon we can get. We can get around 1,750 oil. So this is in terms of kg, and the water is estimated around 900 liters, and the estimated gas is around 9,564. So this is the input and output material, and the entire process, the gross calorific value of the carbon is around 3,000 plus, correct, and this can be used in a power plant. So basically, because of this high calorific value, and while which we are getting, the calorific value is around 7,684 kilocalorie per kg, and that is also used in a boiler startups and can be used in the vehicles, correct. And then finally we are getting the gas, and which can be used for the distillation and heating process. So these are the main case study. We can convert different kind of waste in a usable product. Okay, I think that's all from my end. And if you have any kind of questions, you can ask. So thank you so much.
That was a wonderful talk, and the concept of waste to wealth was really amazing. So it is not only good to innovate, but it is also good to convert the waste products which we are generating in tons into wealth. So that was really amazing. And sir has shared his email ID with us on the chat box. So if any of you have any questions or queries, please feel free to contact him. And madam, would you like to contribute something, Sophia madam?
Yes, Dr. Saurav, it was a very nice session to all of us. We heard Dr. Poddar, but unfortunately he had to go for some emergency work on his business, and he had to leave today only for the airport. So we can always contact him through his email ID, who are the attendees or the participants who are interested to such kind of business development of business models, or how to convert this e-waste into different model forms. So they are always we always encourage our students and participants and even our faculty to join such programs more and more, so that we can have different ideas, innovations in our minds. So with us, we have also Dr. Shaptarshi Ghosh and his students and his team, full of team from NSHM Kolkata Knowledge Campus. And here we are glad to welcome them also, because they are our mentee institute, and we are also exchanging our ideas with our institute with them, and we are also helping them also. We also expect them to give us, they share their ideas on this type of platforms where you can exchange the different innovations and the startup programs. So I think now we can conclude our session. Dr. Shorav, please carry on. And the next talk for this, I think
Yes, madam. Yes,
Mr.
madam.
Pavel will come.
Yes, madam. So yeah, as rightfully put by Professor Dr. Sufia Zaman, today of the Department of Oceanography, we had a very wonderful talk, and now it is time to conclude this session. So I would like to call on Mr. Pavel. So he is a fellow researcher from the University of Techno India University. So he will conclude the session with the vote of thanks. So Mr. Pavel, are you there?
Hello.
Yes, Mr. Pavel, let us hear from you.
Hello. Hello, Mr. Datta. Am I audible?
You are audible, loud and clear.
Yes, yes,
Okay,
you're
okay. Okay, thank you. Okay. Thank you again for Dr. Susanta Poddar for your effort and interest toward this seminar making success, and it's a very relevant issue and relevant topic, as our HOD ma'am, Dr. Sufia Jaman ma'am, already told about this topic, and we always share our student with this kind of view, and that should, they can gain the interest about the environment issue, and this is the burning issue about this particular time, and this is all about the social development model. And now it's time to the vote of thanks, and I would like to thank from Dr. Gautam Roy Chaudhary sir, Chancellor of TIU, and Dr. Rina Palodi madam, Dr. Vijit Mitra sir, Miss Helena Sengupta ma'am, Dr. Shufia Jaman ma'am, HOD of Department of Oceanography, and Dr. Shaptarshi Ghosh from NSHM Knowledge Campus, and their student for joining us with this seminar. And after that, Mr. Dr. Shampa Mitra, Dr. Pritam Mukherjee, Dr. Prasenjit Pramanik, Dr. Navanita Pal, Dr. Orpita Shaha, Dr. Saurabh Datta, Miss Sana Ahmed, and Miss Kritika for their technical support. And thank you all. And over to you, Dr. Datta.
Thank you, Mr. Pavel. That was very aptly put. So we will be concluding our session for today over here. And I would like to remind you all that we have a very interesting session tomorrow. So that will be on startups in artificial fish tank culture. And Dr. Pallavi Datta, who is the faculty member of the Department of Zoology, Charu Chandra College, University of Calcutta. She'll be talking about it. And we are all excited about it because we all like we all have some kind of artificial fish tank cultures in our home or in our surroundings. So that will be an interesting talk. So please join us for the talk tomorrow. And with that, I would like to thank you all for your time and attention. And I wish you a very good evening. And please stay safe, stay inspired. Thank you all.
Thank you all. See you tomorrow again at the same 5 to 6 p.m. We will have another session by Dr. Pallavi Datta. So please join us and make the sessions more brightened up, and we can exchange more knowledge on this platform. Thank you all. Thank you, Dr. Saurabh.
Thank you,
Thank
madam.